Example 3 says, gives you a little background about the Fibonacci sequence. And the Fibonacci sequence, easy for me to say, huh? Starts with 0, 1, 1 again, 2, 3, blah, blah, blah. Not an arithmetic sequence because we're not adding a common difference every time. For example, if you look between 5 and 8 right here, we added 3 because 5 plus 3 was 8. But if I come over here to the end and I look at 34 and 55, 34 plus 22 equals 55. So obviously we don't have a common difference that we're adding each time, which means that we don't have an arithmetic sequence. But that doesn't mean that we can't use a formula as it says, write a formula to model the sequence and use it to find the next term. If we look at the sequence a little more closely, you'll notice that the current term, no matter which term you pick, so let's pick, let's say, 8. If we take our 8, how do we get from 8 to 13? We add 5 because 8 plus 5 is 13. So notice that 5 was the previous term to the 8. So if we take our current term, in our case 8, and we add the previous term, then we get the next term or the following term. So let's check that out and see if it works somewhere else. Let's check out 21. All right. So if 21 is our current term, and we add our previous term, the one to the left, 13, we should get the following term, 34. And we do. So writing a formula can be just words, as we've done here, where we said the current term plus the previous term equals the following term. That's a formula. It works. And so now we've done the first part. We have written the formula. We did that right here. So now let's use it to find the next term. So, as our rule says, our current term is 55. That's our last term currently. So 55 is our current term. Our previous term is 34, so we're going to add that to find our next term that goes right here. So 34 plus 55 is 89. So our next term then is 89.